Hi, so in this video we are going to see how to run a simple linear regression model. So to do that, we're going to use the dataset MTCar, which is the dataset offered by R. So to get some insight about the dataset, you can just type help car. You run it, you see what you have. So from the help car, we have the dataset content 32 observation and 11 numerical variable, but you're going to be interested on the gas mileage, which is in US per gallon, and the weight of the car, which is expressed as WT, and the gas mileage mpg. Now so the question of interest is there any significant linear relationship between the weight of the car and the gas mileage? So that's what we are trying to find out. So what I can do is I can just assign to that data set. So I can just say that G equal to assign to that the empty car. So basically assign to G that data set, and you can type, if you type G, you can see that this is the data set that we have from there. Now what we can do is if I want to access a specific variable, just type G that $sign, I get that specific variable in the data set. So you can see that from here we get only that specific variable. You can do the summary of your data set just by typing summary G. You get a summary statistic for every variable. So for every variable, you are going to have the minimum, the median, the mean, the maximum, the first quantile, and the third quantile. You can also do the summary of one specific variable just by doing that summary of a specific variable. In this case, the cylinder, which is one variable here, number of cylinder, you can see that we had the maximum number of cylinder, which is 8, the minimum, which is 4, the first quantile 4, the median 6, the mean 6.18. So it's always important to check if there's any missing value in your data set. You can just use is that NA, then run that. You're going to see that it's false everywhere, meaning that there's no missing value. If you have some missing value, it should have some true in the table. Now you can do some plotting also, like the box plot, to see if there's any outlier. It's very important to check for outlier. And to know what the function does, you just type help box plot, for instance. You're going to see the description of everything that you have in that function. So here, for example, you have a formula. So in this case, our formula is x equal to g dot mg. So I'm trying to do the box plot of this variable, which is the gas mileage. So I want to label the x-axis, the y-axis. So on the x-axis, I put the gas mileage per gallon. On the y-axis, I put the value range, for instance, and I put also the border. So you can read this to familiarize yourself on what we have there. So I just run that. We have what I have there. That's the box plot. So from this box plot, we can tell that there's no outlier. We are going to see the difference between this box plot and the second one for the weight for the car. Or for example, if I do the box plot of the weight of the car, because you can see that here I changed to the weight of the car, the difference is here we have some outlier. So this is the sign of outlier. Now to fit our simple linear model, we just type model equal to linear model. So this LM stand for linear model. This our response variable, which is the gas mileage, and this explanatory variable, which is the weight of the car. And we are using the data set G. So I just run that. Just give us our model, and I can do the summary of that model just by typing summary, then I pass in model. And then when you run that, you get the summary of your model, basically. So from there, you can see that you have the coefficient of the model. So the equation of we are going to get there. So you can do the summary of the model. I'm going to show how to interpret this a little further when we move further. So what I can do, you can plot again, do some plotting to visualize how that line fit the model or not, if the line actually fit the model or not. So I use the plot function. I pass in, so basically the same expression that I pass in to get my model, and then when I run that, and I have the Y label, X label, the main, which is the title. So when I run that, a plot, you get some point, like some dot on the screen like this, but you can fit the actual line of our model in this graph to see how it fit. So you just use the app line, then you pass in your model. This is the name of the model that we created here. You pass that model there, then you pass the color basically, then you run that, you get the line. This is the line that we use to fit our model. So you can see that there are some points that line on the line, but other points are very close to the line. So this is the best that we can do. So these are probably some outlier that we are seeing from when we saw from the box plot, but we are not going to handle this outlier here. If you want to do a perfect thing, you have to find a way to handle the outlier. But there's another video that we are going to explain how to remove outlier from the data set. Now, you can use the help app line to see what you need, just like any function in R. If you don't know exactly what to pass in as parameter, you just use the help function to get what you need. Now you can use the correlation, you can even check the correlation coefficient of this is negatively correlated. So if you check the correlation coefficient between the weight and the gas mileage, it's going to be negative, which is indeed 0.86, which means that we have the negative correlation, but they are indeed strongly correlated. So we already fit this model. Now you can check the model coefficient by typing model coefficient. So just type coefficient of the model. It's just going to give you basically because you are trying to fit the gas mileage with respect to the weight. So that's how we got this equation. So you have the gas mileage equal to the A equal to the intercept, which is 37.28. So we got this by doing the summary, the coefficient of the model. You can also get it with the summary. And then the coefficient of B, which is B, is negative 5.34. So that's how we get this equation. So basically, this is the equation of this line. So that's the linear equation basically. And you can do some plotting of the model. Just plot the model. So when you hit enter here, you get this line. So you can see that this is the sign of outlier. These are the outlier which we can remove it. If you want to do like a perfect job, you have to remove the outlier for sure. If I hit enter again, you have the normal QQ plot here. It's very close to being normal, but there's still some outlier here. When you have the perfect normal, it's going to be very close to this line. We did it's doing the good job here. So now another curve that is very important is the residual value. So here again, you see that we still have some outlier. If you remove this outlier, you're going to see that this red curve is just going to be being close to this normal, right? To be close to somewhere here. So we can see that is how this Y shape. But if you remove the outlier, it's going to be very close to the center. So that's how you use plot to explore if your model is doing good or not. Now, the same coefficient that we get here, we can also get it from the summary of the model. So if you do the summary of the model, you can see that the exact same coefficient that we have. So this is the y-intercept, which is the A, and the coefficient of x, which is B, is this number, right? So the most important part of this is we are trying to test whether this, if there's any significant linear relationship between the two. So that said, we are trying to test whether if B equal to 0, so one simple question, if B equal to 0, so that said, if this number equal to 0, we're just going to have y equal to A, right? So that means there's no linear relationship between the gas mileage and the weight of the car. So the null hypothesis will be that the null hypothesis H0 is that B equal to 0, and the alternative is that B is different than 0. So for the null hypothesis, to test whether indeed, in general, if there's any significant linear relationship between the two, we use the p-value which is given here from the output of our model. So the p-value in this case is this number, which is less than 0.05 if you use the 95% confidence interval level. So we reject the null hypothesis, and the null hypothesis that said there's significant linear relationship between the weight of the car and the gas mileage. So if this p-value was greater than 0.05, which is our confidence level, we will, if this was greater than 0.05, we will accept the null hypothesis and reject the alternative. So in this case, this number is this p-value is less than 0.05, so we reject the null hypothesis that said there's a significant level of confidence that there's a linear relationship between the weight of the car and the gas mileage. Another thing that we can use to conclude is the F statistic. The F statistic also given here. The F statistic here is a 91.38, which is also very high. So again, this emphasizes that there's a significant linear relationship between the two variables. So these are the two important things. We can also use the adjusted R square as we discussed. So in this case, the adjusted R square is 0.74. Again, very strong, which also emphasizes that there's significant linear relationship between the two. And this same information we can find in the ANOVA table. If you just do an ANOVA of the model, you're just going to have this table. You can see that some of the information are very similar from the ANOVA table. So you can see that this same F statistic is available here in the ANOVA table, which is this number from the summary. The p-value that we have is the same p-value that we have here, right? So either you can use the ANOVA table or the summary statistic, the summary of the model to do your conclusion. So that's what we have for this basically for the simple linear regression model. So I hope this video helps and that you can use this to compare, to check whether there's a significant linear relationship between two variables and how to interpret the result. Thank you.